be live in just a second here, so just remember all of the secret squid talk
will be heard by everyone.
will be heard by everybody. So whatever you reveal now is on the public record.
Sounds good.
I forgot to confirm all the stories, but we'll figure it out. Carolyn, you're going to talk about ghost domes. Pamela, new name for WFIRST, GRBs, binaries. Michael, you're going to talk about AI techniques. I'm going to talk about searching in craters for water ice. So, Nancy, did Nancy get Andy's email? I had a moment on Sunday. I got to interview Lord Martin Rees for an hour, which was incredible. Yeah, boy, what a treat to be able to chat with him. And I was like totally, that was like probably so far beyond my pay grade, and yet he was such a pleasure to talk to. What a wonderful guy.
He's really, really gracious.
Yeah, he was great and so smart. And just, I mean, obviously, he's the royal astronomer. He's the Queen's personal astronomer, and yet he just was so knowledgeable on so many different topics. It was just a joy. I could have just yacked with him, as besties for like hours, but we didn't. Ooh, Pamela's gonna have a good rant today, says Paranor. You're gonna rant today?
I think I got it mostly out of my system.
Okay. Well, see, now I want to explore this.
I have a very stupid rant that I'm capable of ranting about today.
Is it about the WFIRST telescope?
No, because I don't know anything about telescopes, but it is about science tangentially. So if you need that, I'm here for it.
Okay, all right. I'm going to say hi to a bunch of people. That's my job. Hello to Adam Synergy, Andrew Planet, Andy Cowley, Bob Mueller, Brexit Denier, Christopher Senti, Corey S., David Dunn, David Fairweather, Frank Tippin, Ian Farquharan, Jay Brodeur, Johnny J., Kevin Ayers, Nancy Graziano, Paranor, Rich Wilson, Sarguzi, Susan Hunter, and of course everybody who is watching us on Twitch, assuming that is happening. Awesome. Okay. I think we're all ready to go then. All right, Pamela, how's your internet?
I think I'm doing okay. Do I sound all right to you?
Yep. Just don't move. That's the
Yeah.
key. You just stay perfectly still and then just like let the compression algorithm take as long as it needs to send blocks of data. Okay. Cool. Well then let's get into this. Now I want to know what your rant was about. Is it about WFIRST, Pamela?
Yes.
Okay, good. All right. Well, then we can totally segue into this. I'm looking forward to it. All right. Speaker view, back to me. And here we go. Oh, wait. I need my intro. Okay. Here we go now. Hello and welcome to the Weekly Space Hangout for Wednesday, May 20th, 2020. 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about ghost lights in domes and galleries. I have no idea what that means. WFIRST renamed. GRBs requiring binaries. That's cool. AI to discover galaxies and looking for ice in the moon's poles. So, joining me this week, we've got our regular panelists on my screen, Dr. Pamela Gay. Pamela.
Hello, Fraser. How are you doing today?
Doing good. So far, we've been warned your internet may flake out on us, but so far everything is perfect. So just keep whatever you're not doing or doing, just keep doing or not doing that. We've also got Michael Roderick. Michael, welcome back.
Hello. Thank you for having me back.
And we've got who's making mead. Which I want to go into for 1 second here. Honey, yeast makes mead.
I've got some strawberries and some blueberries in there too. Hopefully that'll give it some nice flavor. I have to find out in like 2 or 3 months. So it's a long wait.
That's awesome. I've never actually tried mead.
It's definitely it's your first step, I think, into home brewing and wine and beer making and whatever.
Yeah. So I want to try it. All right. I'll come over. All right. And we've got Carolyn Collins-Peterson, the space writer. Carolyn.
Hi from the Rocky Mountains. And if you like mead, I have a NASA rocket scientist I should introduce you to.
Who makes mead?
Who makes excellent mead.
Oh, that's great. And then let's see. Nope. Before we get on to our special interview, I am just going to remind everybody that they should go and join the Weekly Space Hangout crew. These are, of course, the producers, our friends, our family, who watch the show every week and really organize all of the guests, everyone who shows up on this show. And like, I am absolutely serious. I know I talk about this every week, but each week when we have guests, I had nothing to do with it. I just do my part, which is to interview them, but the people behind the scenes, and of course that I did an amazing interview on Sunday with Lord Martin Rees, the Royal Astronomer, and I had no part in organizing this in the first place. So if you want to sort of use the clout of the Weekly Space Hangout to bring some of the guests that you want to see on our show, you should join the crew and you can become an executive producer. So go to wshcrew.space and they will hook you up. They'll also give you access to the chat that's going on down below. And of course, we are only about a month away from going on our summer hiatus. And so who will you turn to when the space news dries up for 2 months? These people. So wshcrew.space. All right. Oh, David Dunn says that Fraser's more of a Celestron guy than a mead guy. I've never also tasted Celestron. All right. All right, joining us this week, we've got our special guest, Dr. Sarah McAnulty. Sarah, welcome to the Weekly Space Hangout.
Thanks so much for having me.
All right, so this is weird, but you are not an astronomer. You're not a astronaut. You're not a space scientist in any way. You work on squid? What? Who are you? What do you do? Oh, can you hear me?
I can hear you now.
Okay.
Okay, and you can hear me now.
Yeah.
Excellent.
Who are you?
Okay.
What do you do?
What's my deal? Hi, I'm Sarah McAnulty. I am a squid biologist. I don't know anything about space aside from what I've learned running the science education nonprofit that I run called Skype a Scientist. So Skype a Scientist is a nonprofit organization, and we are out here trying to have scientists come into contact with as many people as humanly possible. We typically match up classrooms, scout troops, library reading clubs, any number of different kinds of groups with scientists to have Q&As over the internet. When there's not a pandemic, we also run events at bars. We do stuff at parks, at community centers, all sorts of different stuff. But for now, we're all, of course, online. We do live streams of scientists where you get to ask what you want to know instead of basically the scientists lecturing at people. We're very anti-lecture at Skype a Scientist. And we also have trivia nights for adults every single Thursday, and that helps support our program. It's $5 to play, and it's very silly and fun. It's just a bunch of science nerds getting together, and there are often space questions on there. We have a range of all different scientist types, from biologists, chemists, astronomers, the whole gamut.
And so how did this come about?
Great question. So back in 2017, it was January 2017, the United States was going through a bit of a upheaval, let's say. And a lot of scientists just had a lot of energy and wanted to do something positive. We noticed that a lot of messaging from within science was kind of just staying in our bubble. And we wanted to think about ways to break out of that. And so I started the program then. I thought we'd maybe get 100 classrooms to sign up to the program, and 800 signed up in like a month.
Yeah.
And so that was like, oh my God. Like, first of all, people want to be talking to scientists.
Yes,
and
absolutely.
Scientists want to be talking to people. 500 of them signed up. And so ever since, we've grown so much since. We've really been like overwhelmed by the amount that scientists really want to engage. And a lot of times they don't quite have the bandwidth to be like running their own events, starting a series, something like that. But if they can just hop in and participate in a structure that kind of just hands them a task, that's much easier to fit into your busy scientist schedule.
Right. And so you can show up as a scientist, you can answer a bunch of questions for kids or for special interest groups, but not have to necessarily prepare some sort of lesson plan or, yeah, I can confirm
Exactly.
that is, it's very easy cognitively to just talk about the things that you do without necessarily trying to put it together in some kind of structure. And so is it like one-to-one? Like if you are a teacher, you can request a scientist to be to show up on in your class.
Exactly. So if you are a teacher, you can ask for any one of 30 categories of scientists. You can ask for a woman scientist. You can ask for an LGBT scientist. If over half of your group is of a given underrepresented group in STEM, you can also tell us that, and we'll preferentially match your group with a scientist from the same underrepresented group so that hopefully the kids in your class have a positive role model actively in science.
Yeah, that's cool.
That is as relatable as possible. Totally. Yeah. So, but yeah, it's one classroom to one scientist. We generally ask that there are 5 people in the group to sign up. But during the pandemic, we know that a lot of folks are stuck at home, maybe with only 2 people. And so while COVID-19 is a problem, anybody can sign up. If there are kids around, we just ask that a parent or a guardian, some adult, is present for the session because we just think that that's safer.
And
yeah.
so how long do these sessions tend to go on for?
About a half hour.
Yeah, okay. And what have been the results? I mean, have you found, I mean, one of the things that I always find so amazing is, the more time you spend doing this kind of public outreach, you start to hear these incredible stories about how, because of the conversation you had, people have gone back to school, or they have, have you had some of those kinds of stories? People are sort of getting really inspired again.
Yeah, absolutely. I mean, there have been so many people reached by our program that we get a lot of feedback kind of constantly. So for 2019, we reached over 9,000 classrooms, and this year already we're approaching 6,500. We have a lot of groups that we match every year. And whereas I'm not physically in these places because our work is distributed over thousands of scientists, I don't always really see the impacts directly, but we get emails from teachers, from parents all the time saying how influential these things that kind of feel simple, like a one conversation, doesn't seem like a lot, particularly if a scientist has come from a background with a family full of scientists. One conversation may be like, well, that's just a one-off thing. It's not that impactful. But as a person who grew up in Philadelphia in a family that had no scientists, that's huge. That's amazing. Like I would have loved to have met and talked to a squid biologist when I was a kid.
Yes.
Especially a female squid biologist. I would have been over the moon about it.
Yeah.
And so we really have to think about, how unique these experiences can be for a lot of people.
And I think the key is the other way as well, which is that, for the people who are getting a chance to meet the scientists, it blows their mind. But I think it's really valuable for the scientists to spend some time interacting with the public that is consuming their content. Nothing sharpens your mind and gives you new, fresh ideas than getting a chance to just talk to people. You're going to get a lot of the same questions, but sometimes you get some pretty insightful ideas and questions coming from the people that you're talking to.
Yeah, I mean, so one time a second grader came up to me and said, "How do squid live?" I'm like, what? Like, how am I supposed to answer that question? That's like such a meta question, but I love that. And we also, a lot of times, we assume that kids, because they don't know as much as us, aren't as sharp as we are. And that's just not necessarily true. A lot of times when you have someone who's never thought about your field before and hasn't been trained to think in the same structural ways that you have, they may come in with these naive questions that really kind of blow the lid off of everything you're thinking about. And so having someone who's naive to your field come in and ask a question can actually be incredibly helpful for scientists. Yeah. And of course, being able to practice communicating is also incredibly valuable.
Yeah, absolutely. And that's the other thing. And that's like one of the whole reasons why we do the weekly Space Hangout is to give science communicators a platform, a place to be able to practice interacting with the public in a way that is, low stress. And so I think that's any chance to be able to do that, I'm sure is very valuable. What's the plan now? I mean, as we kind of get through COVID, is this, you know, do you have plans to kind of roll this out in other ways, into other venues moving forward, or just keep scaling it up?
Yeah, during COVID, we have scaled up our live stream series. We typically would do 3 a month, and now we're doing 3 to 5 a week, because there's a lot of folks that maybe don't want to spend a half hour with a scientist and just one of their kids, for example, but are willing to join into a Q&A live stream kind of situation. So we've had a huge increase in what we offer and also in our audience. We've been delving into a lot of just sort of like experimental science communication, where we just kind of try stuff and see how it goes.
That's awesome.
And once we're allowed to go back outside, we'll do more of that. Because the real challenge when you're online is, how do you reach people who don't seek you out? Because online we are very siloed, and it's very challenging to break out of your silo.
Yes.
And so that is something that we have, and many other science communicating groups have really been struggling with during this time. And so we're just kind of producing stuff for the people who need it right now, and then going back to our really reaching out of the bubble programming once we're allowed outside again. We're also focusing on getting some free science communication training up for our scientists.
So do you have any shortages? Are there any
No.
kinds of scientists? I mean, you mentioned like some of the underserved communities. Are you looking for more people to come from some of those backgrounds?
Always, 100% of the time. We love, we know that underserved folks who come from underserved groups are often overtaxed in outreach broadly. So we acknowledge that they may already have too much to do, but if they're willing to come and join our database, they are super valued, because they get snatched up right away by the groups that sign up. But we have plenty of scientists to go around right now, which is amazing. But if you know of any teachers, scout troop leaders, folks with kids at home that are looking for something to do, tell them about our program. It's totally free to participate. We want to make sure that we're accessible to everybody with an internet connection, which of course doesn't mean we're accessible to everybody, just everybody with an internet connection, but that's as best as we can do right now.
Yeah.
Tell everybody you know about our program. Tell them to check us out.
Okay, so if you are someone that wants to, I guess, host a scientist, go to Skype a scientist, and there's a place to sign up to let you know what you want. And if you are a scientist, there's a place you can volunteer your one-on-one time.
Yep.
Perfect.
Skypeascientist.com.
Awesome. And if people want to follow your work, where can they go to see what you're doing?
You can follow me personally at Sarah with an H Mac Attack, Sarah MACK Attack, on Twitter, Instagram, and TikTok. You can follow Skype a Scientist on Twitter at Skype Scientist, and then on Instagram at Skype a Scientist. We our program day, so you get a sense of who is in our roster.
Fantastic. Well, thank you so much for taking the time to chat with us today, and good luck with both the squid and the and all of the science outreach that you're doing. It sounds amazing.
Thank you so much. Thanks for having me.
Take care.
Bye-bye.
All right, let's move on to the space news this week. All right, Pamela, I'm intrigued. I've got to know, WFIRST got a new name. You're muted, I think.
Sorry, I have to be consistent. I always start muted.
Yeah.
So earlier today, there was what may have been one of the oddest formats of NASA announcement ever. There was an email that went out Monday saying, hey, big announcement on NASA TV, YouTube, all the normal links, where you expect there to be a live event. And it turned out that they were using the YouTube Premiere feature to show a pre-recorded video.
Yeah.
That's not the controversy. So in this pre-recorded
I
video,
do that. That's fine.
You don't put out press releases about it, though.
Only because I'm not organized enough. I would. If I had a little more time, I would put out a press release that I'm going to be premiering a new video. But I know what you mean, that whenever those NASA press releases come out, half of the game is what are they going to announce? Did they discover life on some exoplanet?
Right.
Yeah. What did WFIRST canceled?
So Well, they said they were had a very exciting announcement, so I canceled. Now, what they announced is they are naming this space telescope, which is going to do, if it is allowed to continue, and if it launches successfully, they're going to name this tremendous new instrument after the first chief scientist of NASA, who was a woman, and
Chief
this
astronomer.
is Nancy. Yes, that's what I meant to say. Sorry.
Yeah.
NASA's Nancy Grace Roman. And this is perfect. This is exactly the person you want to celebrate with a space telescope, because she was one of the forces of nature who pushed for the development of the Hubble Space Telescope. Now, where I personally found myself raging against the machine when I saw this occur is WFIRST has had a very trying existence for the past several years.
Uh-oh.
And repeatedly canceled from the president's budget. It has been mocked on social media by leadership. The scientists who work on WFIRST and the other team members who work on WFIRST have had their travel funds restricted so that they couldn't go and share what they were doing because folks didn't want to offend the president. And so basically, this is a mission that has been threatened with constant cancellation and had its people silenced. And it's a little bit on the nose to name it after a woman.
Right.
And human beings, whether we want to be or not, are superstitious creatures, which means if the first space telescope to be named after a woman is ultimately canceled because Trump gets his way with the NASA budget, that's really a bad
It'll
thing
just,
to
you know
do.
what? It'll just mean that it just goes on to the Louvre. They'll just get bigger and more powerful telescopes. Her name will be shifted. So did NASA make any other announcements beyond the name?
No.
Okay, so all we got today was the name. Okay, so
Yes.
So tell us a little more about Nancy Roman.
So Nancy Roman, she was an astronomer who worked doing ground-based astronomy. And 6 months after NASA was formed, in the early days after World War II, she joined NASA as one of the people who said, this is an organization that isn't just going to put humans in space, but we're going to do science. And all across the years, she was looking for ways to use ground-based facilities to support NASA, to support its science, and pushing to get that telescope on orbit that would allow us to be above our atmosphere. And to be one of the early women at NASA, she had to be one of the early women in astronomy. So she was one of the first PhDs post the Harvard College women. And she was certainly in the mix with all of those people professionally. But at the same time, very much like we've seen with Katherine Johnson, she was someone who never talked about, well, what it was like to be the first woman, simply saying, look, I got the job done. Her middle name, Grace, I think it's always stated because she did carry herself with so much grace. Really, this telescope could not have been named after a better person. My objection is the timing. Traditionally, they've named telescopes only after the mission has been commissioned. In recent years, this tradition has been thrown away. The last time it really was done beautifully that I recall was with Fermi, the glass telescope. After it had been launched, when the commissioning images came down, the new name and the commissioning images were shared pretty much at the same time so that the family could be part of the celebration of the fully functional telescope.
Right.
And so they chose entirely the right person at entirely the awkwardest of moments. And it was a little bit on the nose,
Do you think it adds? Do you think it adds like any more weight now that this thing has a name?
Yeah.
It's a little bit more finalized that like now it has to go through or anything like
well,
that?
it depends on your perspective. So on one hand, it's a whole lot harder to say we're canceling the Nancy Roman telescope than it is to say we're canceling WFIRST.
Mm-hmm.
At the same time, historically, it's been really easy to cancel women. So now we get to see how this plays out. This reminds me of hurricane research, where it's been found that people are less likely to evacuate when there's a Cat 4 telescope named after a woman than a Cat 4 telescope named after a man. Everything can be identical except for the gender of the name, and it massively impacts whether or not people evacuate. So we're finally going to see how gender politics play out in the naming of a telescope.
Yeah, so I think, like I said, I think the solution is that NASA just says whatever is the next telescope is going to be named Nancy Roman until that her name gets into space, because she is one of the most important people behind NASA's entire space telescope project. You're gonna have to cancel every single telescope that will ever exist until the end of time, because that is the next name for a telescope.
I like the way you think.
There you go.
I just don't think that's how it works.
Can
we put you in charge?
Sure,
It
yeah,
might be
anytime.
more
Anytime
interesting.
you want to let a Canadian run NASA, just let me know. I'm there.
Sounds great.
All right, that's awesome. But still, congratulations. I mean, I know she passed away just a couple of years ago at 93, but what a great name for a telescope. So. All right. Carolyn, what do you got for us?
Learning how to unmute my mic. Yeah, I just need to follow up on the Nancy Grace Roman thing. She was one of the very first people I ever interviewed for my first book about Hubble, and we could have talked for weeks. She was so knowledgeable and so helpful.
Oh, yeah.
Yeah.
Yeah,
so I was kind of sad when I saw that she
dangerous,
died.
right? When you have somebody who is that knowledgeable and generous with their time, you just, it's like you just keep asking more and more questions. You keep following your curiosity. Yeah, I know. And then, and they're generous and you're curious, and it just goes on forever. Yeah.
And in my case, I was still learning all the history. Yeah. And I was still learning all the history. The second person I interviewed after her was John Bacall, and that was a totally different experience. But anyway, yeah. So what am I talking about? Well, as most of you, or I think a lot of people that read me know, I've been involved in planetariums for a long time as a producer. I worked at a planetarium when I was in college and before I went back to graduate school. And as the pandemic started to roll and all of the lockdowns started, I was watching as all of the domes started to close. And it was really a difficult thing to watch, because these are all my friends and my colleagues are either losing their jobs or they're going home and they're not being allowed in their domes. And I was sitting there thinking about, what can I write about this? Because planetariums and science centers are pretty big deals when it comes to communicating science to the public. And that voice is gone for right now. It's shut down, or at least it was for quite a while. And so I got to thinking about it, and I saw an article the other day about when theaters shut down, they always leave a ghost light on in the theater. So like on Broadway or wherever, there's always a ghost light to let people know that the show will go on at some point. And usually that's on Mondays when theaters are dark, but now all theaters are dark. There are no musicals, there are no plays, nothing like that going on. So there's a ghost light. And I was thinking, do domes have ghost lights? And did people leave them on? And I don't really have a good answer to that. But metaphorically, the ghost light is that the planetarium community has not taken this lying down. They've actually they had to shut down. There was no way that they could let people into theaters. You can't social distance in a dark room full of 100 other people or whatever. Or if you have a little
that'll be the last dome, place to open up is going to be
and make everybody wear a mask, right?
Yeah.
And so along with all the museums, the planetarium shut down. For the first few weeks, it was like everybody was in a state of shock, and we all started getting together on social media, and we have little meetings several times a week, and we have hospitality suite on Thursday nights. Everybody brings a drink and we talk about what's going on, and it's all on Zoom, by the way. And people started talking about, well, we need to be able to engage our public. And so the ghost light that I'm really referring to is that they've gone online. The planetarium people a lot of them are putting things on their websites. They're doing Skype calls. They're doing whatever they need to do to bring science back out into the open, particularly astronomy and space science. And so that was what I was writing about, is that, we have these cultural and scientific institutions which are closed, all the museums. So like, for example, the Denver Museum of Nature and Science, the Adler Planetarium, the American Museum of Nature and Science, we've been seeing huge layoffs from those places. And the general thinking and from the discussions I've been able to follow online is that most of these places are not going to open up before midsummer, maybe this fall. The school facilities are the largest numbers of planetariums, and they are not going to be opening until the schools do. Some of them said they will not be putting students into the dome until they can enforce some kind of safety in terms of social distancing, wear a mask, how do we clean the theater between shows, how do we sell tickets, all this sort of thing. But so it may seem like all these domes are quiet with little tiny lights shining in the middle of the dome saying the light will come back, the stars will come back, but planetarium people have moved online and they've started to do their teaching and they're discussing with each other and learning from each other so that they can take it back to their administrations and say, okay, when we do open up, here's what we as planetarium people at the museum or the school or the university can do to make sure that we can continue our mission and do it safely in an age of coronavirus.
Yeah, it's interesting to see, each of these fields is trying to figure out how do we adapt what we do to online. Yeah. And I think the discovery that a lot of people are going to make is, in fact, when you have some really interesting story to tell about space, and you figure out a way to tell it online, you will actually potentially impact more people than you would have just having it in your museum and only the people who happen to come by the museum and only the people who happen to buy a ticket that day to actually see it. Like there's something, there is a much wider audience out there. These people are going to get a chance to explore this content, especially, again, places where people are too far away from a museum. They can't afford to go to a museum. They don't have access to this kind of knowledge. And suddenly now they do. So
it's interesting. One of the planetariums that's been talking about having online shows did an online show the other night, and it drew so many people that spammers showed up and started to sell tickets for it and rip people off. So they it's successful, but it's a little too successful.
Yeah.
But in the meantime, people are saying, and they are surveying, and there are some pretty big surveys going on now about when people do intend to start going back to, and mostly from museums and cultural institutions, going back to these places. And the latest one, that I saw said that people would be willing to go back, but not within a month of reopening. So if you reopened in July, you might not start seeing people coming back till September.
Yeah, I mean, we're not so bad here in Canada. I think we're seeing, we haven't had any cases on Vancouver Island for apparently better part of a week now. British Columbia is still having a handful every day. Canada's still growing. I mean, we're still going up several thousand cases a day.
Really?
Yeah. And then mostly in Quebec. And so, I mean, maybe we'll start to open some schools up. Definitely not the kids' schools before summer, but maybe we'll have things like universities and stuff by the end of the, back into fall. But still, I think it's going to be super dicey in the US. You're looking at next year sometime when the vaccine is out and everything is safe. I think it's madness to think
that is exactly what people are saying is I don't want to open my dome or my district won't let me open my dome until there's a vaccine. And it could be 18 months away.
Yeah.
I mean, vaccines don't just kind of flash into being. It's not Star Trek, where you go to the replicator and say, give me a vaccine. It takes time.
Yeah. So that is the challenge is this isn't just, let's just tinker around a bit and then see what happens. This is, let's spend the next 18 months trying new ideas and figuring this out and then see what happens.
Well, and that is what they're doing. I mean, and so part of my thing is, I service planetariums and I have friends and colleagues in it. What's been fascinating to me is to just watch how they've adapted, how we've all adapted to be able to share our science and share whatever we need to do. At the same time, dealing with these very mundane questions of, well, when we do open, who's going to clean the seats?
Yeah.
Or things like that. Or if we sell tickets, do we need ticketless entry now? We don't even handle a piece of paper or money and all those things they really didn't have to think about before.
But I mean, from what we're really learning, being outside isn't a problem. What about is less of a problem? What about doing giant events outside somewhere where you somehow broadcast the planetarium view onto a large screen or,
in fact, they are
adapting
talking
things
about
that.
Yeah. There's a fellow in Florida who's basically, I think they're planning to do this, go out and do something in a large parking lot where they have loudspeakers set up and they do a star party. Yeah. So it'll obviously be the brightest things, but yeah, or like there is a plan for a nationwide star party. I'm blanking on the details right now, but where people will be able to log in, and planetarium people are going to be getting in on that to say, okay, we'll do this star party in July or whatever.
Yeah. Well, we do our star parties every Sunday night. And so if you ever know of some planetarium director who wants to just explain some of the stuff that's up there in the night sky, we're good at operating the telescopes. We're less good at having any contextual information about what it is that we're looking at. So
I'll pass that along.
Yeah,
I'll pass that along because there's going to be a session tomorrow. I'll pass it along.
Yeah. So we can very rapidly move from object to object, bringing up galaxies and Saturn and all that good stuff. But we're just like, oh, it's another galaxy, moving on. But actually, no, it's there's a supernova going on in that galaxy right now. So
the coma cluster again. Yeah. Yeah.
I got a fuzzy bit. I got another little fuzzy blurry bit. Who knows what that is? Moving on. So yeah. Awesome. Good luck in helping figure this out. I sure hope that they can. I mean, obviously for me, and I'm sure for many of the people, planetariums are key to our childhood. What got us into this endeavor in the first place, and to know that these are offline, that these will be the last things pretty much that get opened up in the end. Yeah, jamming a couple hundred people into a small room with poor ventilation in the dark.
Well, yeah, and just to finish off on that note, most of them are saying they're going to have to cut as many as 2/3 of their seats, maybe 3/4 of them.
Yeah.
And if you're a little planetarium, that travels around, little inflatable that only gets 10 people in anyway, that's 2 people or 3.
Yeah, and they're learning. So, they're learning that even like indoors, 6 feet isn't even enough. That it's more like 15 feet is safe, and that's just like not feasible at all. So
yeah.
Michael, what have you got for us?
All right, so trying to classify galaxies using the computers. So the kind of headline for this one is, AI is looking for galaxy classification. Oh, it's not really an AI, it's machine learning algorithm. You can't ask me how it works because I don't understand machine learning. That's kind of magic for me.
You take a galaxy and you show it to a computer, like you just hold up the picture and you go, galaxy.
Find more.
Yeah. And then you take the picture away and then you hold up another picture and you in front of the computer, you go, galaxy. And then you show something that like a cat. Mark. Yeah, you go cat and you go, not galaxy. That's how it works.
Hot dog or not hot dog.
Yeah, exactly. Hot dog or not hot dog. Yeah, precisely. That is machine learning in a nutshell. And I'm the one with the computer science degree, so that you can take that to the bank.
All right. So for their training set for their galaxies, they did use real Hubble data. So there's a deep data called the Candle Survey that had a bunch of images of galaxies. And so, like you said, they kind of fed this into the algorithm. It did its magic, and it can now classify different kinds of galaxies. So this is unique in that it will go pixel by pixel in each image, and it will try to classify, is that pixel part of a spheroid? Is it a disk? Is it an irregular? Is it some compact object? And so at the end of the day, what this will output is essentially a complete representation of the image that you fed it in, and each pixel will have a corresponding classification for it. So is an elliptical galaxy, is a spiral galaxy. And so in doing that, you are able to look at millions of galaxies all at once. So doing this by hand, classifying galaxies, is pretty time consuming. It's more than any one graduate student could do, or even 2. And so what has been done in the past is there's been this project called the Zooniverse, the Galaxy Zoo. And so this is a citizen science. You've probably heard of it.
It's possible that one of the people who's in this event right now was one of the people who worked on it in the first place.
It's a pretty cool system.
Pamela waves.
And so the amazing thing about this is that, the citizens themselves can actually do science, contribute to research, and you get these huge numbers of people that you're throwing out the data, and so they can go through so much more data than any one person could. And so we've got this big project, hopefully starting up in a few years, called the LSST, or now the Vera Rubin telescope. And that thing is going to be taking, I have it here, 800 images each night, 20 terabytes of data each day. It's an insane amount of data. So with this algorithm, then hopefully they can feed it all that data. It can go through, classify all these galaxies, and you can kind of take out the citizen science, and you can put them on some other more meaningful project than astronomy. Not that there is.
So, Pamela, I've got to ask you, we've had this conversation so many times about how there are certain tasks that computers are really bad at, and one of them for the longest time was this exact thing, and that was why you and your friends developed this application in the first place.
Right.
Is machine learning now at the point that original project as it was envisioned is no longer required?
Not to the scale at which it was originally done. So when we first founded Zooniverse back in 2009, it was with the understanding that software was nowhere near able, no matter how well you trained it, to identify galaxies, craters. It's still not very good at craters. But about 4 years ago, a massive change in the ability of computer vision, and especially the machine learning algorithms coming out of some of the Google teams, really was able to say, look, give us 10,000 examples and we'll do the rest.
Yeah.
Now, what's going to be important moving forward is using humans to figure out the training sets. So the future with the Large Synoptic Survey Telescope at the Vera Rubin Observatory is going to be, each night the software is going to go through and go normal spiral, barred spiral, elliptical, no idea. And those no ideas are going to get cast out. And once you get enough of this same sort of new object, you can then retrain the algorithm to add in these new objects. So as we discover new classes of objects, once we get enough examples of that new kind, with human beings being responsible for identifying those new things, we can just keep updating the algorithms. And without these algorithms and the matching humans, we have no hope of being able to deal with the throughput of data that's going to come out of LSST. So it's the human-computer collaboration that's really our best next hope for the future.
And it's funny, like we live in this age of these algorithms, as you talk about this, and a lot of people don't realize they've only really been in development now for the last maybe about a decade or so, and more recently there are these things called the generative adversarial networks, and this is where you essentially pit two computer programs against each other. One tries to make a fake person or a fake cat, and then the other one tries to figure out what's a fake cat and what's a real cat, and there's been an absolute revolution. It's really just finally we've gotten to the point that the brute force of computers is able to do this, and so it's very stunning. But I like that idea that essentially, as we get faster and faster at learning the new kinds of things that we want to discover, we can train the computers on that data, and then they can take over and just search petabytes of data every day to find more examples of those things. And that's just sort of an amazing idea of the state that we're at now. I love it.
And the real trick is just going to be getting the computers to figure out where there's unidentifiable things.
And for the poor people who spent a little while classifying rocks on Bennu, for example, I mean,
that we couldn't do with a computer. That still can't be done with a computer.
But you can imagine a future where we have plenty of spacecraft orbiting plenty of asteroids, and people are teaching and checking, and then the computers are trying to figure out the rocks from that point forward, or the craters, or whatever.
Well, the problem with these sets is each object requires a different training set.
Yeah.
And so when you have an itty bitty little tiny surface, here we need to be able to train faster than we currently can.
Yeah.
It just requires too much data, and the entirety of Bennu isn't enough to train an algorithm.
Very cool. All right. And Pamela, since you're on my screen, you've got another story to talk about today, right?
I do. There was one of those stories that made me realize once again, and this is a recurring, yes, I love this realization. You have to be super creative to be a scientist. People often poo-poo scientists as just linear thinkers, but sometimes you have to not just think outside of the box, but just like create an entirely new box to think in. And for the longest time, we've been trying to figure out what are long period gamma ray bursts, these gamma ray bursts that can last minutes and minutes at a time. We've been trying to figure out what they are by starting with a single object model. And we've been blaming various physical characteristics as the possible reason that one massive star, when it goes supernova, just explodes normally, while another one will have these massive jets that generate the gamma rays
and sterilize all life on Earth from halfway across the galaxy.
That could be true.
Yeah.
But as it stands, nothing really fit. People kept trying to blame the spin rate of a star, but the necessary rates just weren't found in nature. And a team in Europe of many different institutes and many different collaborations of institutes threw their brains and their computational power together and realized that if you have a massive star burning carbon and oxygen in its core that is about to end of life in a binary system with a neutron star, when that massive star undergoes core collapse, it will form a new neutron star down in its core. And the outer layers of the star that fly off are going to feed that pre-existing neutron star with a whole lot of material. And in some cases, even generate a black hole neutron star binary. And it's that companion star that ends up with a fast-moving accretion disk around it and this massive plasma field of material to feed upon. That companion generates the jets. So when we're looking at a gamma ray burst, a long period gamma ray burst, what we're seeing is a regular supernova from a carbon oxygen burning massive star that becomes a neutron star, and a compact object companion star that in some cases is going to become a black hole, in other cases is just going to become an even fatter neutron star. And it's generating jets from a temporary disk that peters out in rapid fashion.
This is kind of amazing.
It's awesome. The creativity to just say, oh, wait, let's just add a second star. We've gone 2 decades without anyone thinking of that.
Well, I'm sure people have thought about it, but the key is, can you make some kind of observation that match? I'm sure someone said, I wonder if there's some kind of binary event. So, but to sort of imagine that interaction where you've got this star and a neutron star orbiting around each other, the second star dies, there's a neutron. Now there's a neutron star, right, with a supernova, and then the second star almost like kicks it up into the next level, and that's what fires the beam. That is amazing. And this just came out like yesterday, right? This news.
Yes.
Okay, I'm totally doing a video on this. This is so cool. I had no idea this discovery had been made. I'm stoked.
It's a really cool, and they have Fermi observations and X-ray observations that match everything that they're finding. It looks pretty solid.
That's amazing. Finally, an answer for gamma ray bursts, or part of the answer anyway. But that's amazing. Yeah. All right. So I'm going to talk just a little bit here about a cool program that's being done by the European Space Agency. So, of course, people are going to be going back to the moon. And, of course, by 2024, humans will be walking on the moon. The focus is going to be on the moon's southern pole. And so because you have these permanently shadowed craters and large deposits of water ice that are down there. And so there's kind of 2 interesting parts to this. The first thing is that NASA has announced they're going to be sending a spacecraft called the Lunar Flashlight, which is going to be a CubeSat that's going to fly over top of it's going to orbit the moon. It's going to fire 4 infrared lasers into the craters on the moon, and then watch how the laser light bounces back. And if the laser light bounces back very well, that means it's hitting rock. But if the laser light gets absorbed, then that means that it's various volatiles, water, other things frozen onto the surface of the moon, have been there for a long time. So hopefully by the end of this mission, NASA will know very well how much of this water ice is located in these craters. And so then the second question is, how do you explore this? How do you examine it up close? You want to send a rover, but the problem is that they're in total eternal darkness. And so you can't use a solar-powered rover, obviously. So you would send a nuclear rover, right? You would send an RTG like what Curiosity has or what New Horizons has. But the problem is that these give off a ton of heat. And so as your rover is crawling towards the sensitive water and ices, it's blasting it with heat, and you're essentially ruining the samples that you're having to make. So the European Space Agency has been testing out this idea where you shoot a laser at your rover, and you're able to power the rover from afar from some sort of base station. And so the plan is, right around these eternally shadowed craters on the moon, there are also permanent sunlit mountains on the moon. And so they'll put a lander on one of these places. They'll fire a laser at the rover and power the rover. The rover will crawl down inside the crater, do its science, and the whole time it will be able to communicate back and forth with the lander using this laser. And ideally, in fact, you will have astronauts up on the Lunar Gateway, assuming this is a thing, who are remote controlling. And again, the European Space Agency has been testing this idea out. Luca Palmertano, when he was up on the space station a few months ago, was able to fly by wire, essentially pilot a rover down on the surface of Earth while he was orbiting on the International Space Station. So you've got all the pieces now to actually go and find out if there is this water ice in large deposits on the surface of the moon. And if that sounds familiar, it's because I did a video about that today, but I've been so excited about practically how people are going to be able to find these. But I want to show you a cool picture of the rover itself. So ESA released this image of the rover, and they've been testing this rover out in Tenerife, and so far it's been working great. They've been able to actually power this rover and move it around on the surface at night using a laser, and it's working like a charm. So that could very well be the future for that and other missions as well. This idea of remotely delivering power to something is pretty exciting. All right, well, we've reached the end of our hour. Pamela, you're on my screen, so why don't you tell me what you're working on and where people can find out more?
So we are continuing to work on redoing CosmoQuest as an entirely open source project. So I'm working on a database merger, but along with that, we are producing the Daily Space every day at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. And we invite all of you to tune in to twitch.tv/CosmoQuestX and get a fast-paced rundown of all that is new in space and astronomy, and then go get the long videos from Fraser after.
Michael, what are you working on? Apart from mead, or including mead?
Apart from mead.
Yeah.
The mead is fermenting away. I don't touch that for a while. Hopefully it turns out okay. We are going to try to do an online Astronomy on Tap session. So obviously we have not been able to do these at our normal restaurant venues. So in the month of June, we are going to hopefully bring some online Astronomy on Tap for you. It's going to be on our YouTube page, Astronomy on Tap State College. So stay tuned. My Twitter is @MichaelRoderick. And once we get this all set up, I'll tweet out the link and hopefully see you there.
Great. Carolyn.
What am I working on? Well, during the pandemic, I've been writing a lot. I'm working on some content for Planetariums and some online material. I've also been making masks for a lot of people around here. Little masks just to help, just because I have a lot of space material, so I'm making space masks. And I'm also doing some training on some specialized planetarium software, learning all the new tricks about Digistar 6. So it's been keeping me busy. If you want to read my material when I am writing online, I'm at thespacewriter.com, and I'm on Twitter at @spacewriter.
Fantastic. All right, so people have known we've done the Star Parties are back. We've done 2 now. We're going to do our 3rd one on Sunday night at 8 p.m. Pacific, 11 p.m. Eastern, but that's a rough guideline. When we start sort of depends on when the winds die down, when the telescope doors open, when people's internet connections work properly. So, don't yell at me if we start a little late, but we've had a great time. Last week's episode, we just gazed right into the heart of the Virgo supercluster, which was kind of amazing to see all these galaxies, and it was a lot of fun. So if you want to come join us, more astronomers joining us each week, we'd love to have you, and so that'll be on my YouTube channel. And I think we're going to have an astronomy cast on Friday. Do we know what we're talking about, Pamela?
We do, but I no longer remember.
Yeah, me neither. Nancy remembers. Someone will say it. All right, and I think I'm just looking at Nightbot is saying we've got 1, 2, 3, 4, 5 more episodes of the Weekly Space Hangout before we go on our summer hiatus. So don't forget, go to the wshcrew.space and join up and be part of the community. All right, I'm going to put everybody back on the screen, and I'm going to thank everybody. Thank you for all of everyone watching us today, both on YouTube and on Twitch. Thank you to all the moderators. Thanks to Nancy Graziano, especially for everything she does, and my co-hosts and our special guest. We will see all of you next week. And I'll say that 5 more times. 4 more times? 4 more times. Thanks, everybody. Oh, extreme binaries. There you go. Oh, good timing. All right.